All right, you guys, we are back. Hope you've been doing good. I hope you did all right on lesson 12-6. Remember the last thing we did was we've talked so far about all the different ways we can prove if two triangles are congruent. So before we get started on lesson 12-7, I want to make sure that you guys understand some of the properties that will help us make sure that we know some things are congruent, or we can tell some rules about some different items. So they want us to name the properties that are illustrated here. Well, okay, I have a segment RU, and it is congruent to another segment WX. Well, then they say that WX is also congruent to YZ. Okay, well, if that's true, and these two are already the same, WX is the exact same for both, then our illustration says we can link RU with YZ, and that's what they do. And they link it with RU is congruent to YZ, the two segments. So basically we have three segments and they're all the exact same length. These two have never been talked about together, but they're linked with one that's the exact same. And so it's like me telling you a story, and then that person tells another person a story, and even though me and the other person haven't talked, it's as if I have told them the same story. It's kind of like perfect gossip, even though that's not the way gossip really works. But we call this the transitive. Transitive rule, okay? All right, the next one is angle A is congruent to angle A. Well, that's reflexive. That's like looking in the mirror. Reflexive rule, okay? Number 3 is if angle B is congruent to angle C, then angle C is congruent to angle B. Well, it's kind of like there would be a line right here, and we flip this over and it lands right on that. We call that symmetric. So we've got symmetric, we've got reflexive, and we've got the transitive rule. Okay? All right. So what does this one look like? Well, JK is congruent to JK, that's reflexive. So anytime two things are exactly the exact same, it's like looking in a mirror, we call it reflexive. Okay, let's see what this one is. Segment LM is congruent to segment NP. Well, segment NP is then congruent to segment LN. Well, if I flip it over, it lands right on top of itself. That's like the symmetric. Okay? And the last one, angle Q is congruent to angle R. So that's two angles that are the same. Then they say angle R is also congruent to angle S. So that's a different angle. Well, then we can conclude that angle Q and angle S must be the same. Well, they're linked. The two angles that never saw each other, these two angles never were around each other, but they are the exact same because they are congruent to the same angle. We call that transitive again. Okay, so those are the rules. Those three rules help us every single time when we're doing some of these things, okay? All right, well, let's go ahead and talk about different ways we can name angles. All right, I want to remind you of the different ways we can name angles. This angle can be named three ways. We could name this angle angle B. When it's a single angle, you can use one letter. You can also say angle ABC, and we could also say angle CBA. Notice B is the angle we're describing. Okay? And you can use three letters to do it, or one single letter if it's a single angle. But let me remind you, you can never, because like if we had, there's multiple angles right here, and if we had A, B, C, D, and E, let me remind you, there are multiple angle B's right here. You could never just say angle B on this thing, because which angle B are you talking about? Okay, so this one you definitely could never say angle B. Okay? All right, well, let's do this one. This one can actually be named in four ways because it has a little number describing the angle. So we could say angle 2. We could say angle K. And now we can use the three letters. Angle J, K, L, angle L, K, J. Those are the 4 ways you could name this angle. All right, this angle right here could only be named in 3 ways. We could say angle M. We could say angle HMN. Sorry, my N is a little bit squibbly. All right, and angle NMH. Those are the only 3 ways we can name that angle. I can't use a number because there's not a little number inside there. Okay, and that number does not signify how much that angle actually, the degree of it is. It's just describing the angle. So this one would be angle P. It could be angle MPR, and angle RPM. And that's the 3 ways we can name that angle. So there's different ways you can name angles. It's important to be able to recognize which way that you can do it. All right, the lesson itself. Using congruent triangles. We're going to use information we know about congruent triangles to help us solve problems. All right, well, let's take a look at what this surveyor is doing. It says the figure shows how a surveyor can measure the width of a river by measuring only one side of the river. And the study the figure, then explain how the surveyor can actually do this. Well, based on what we know 5 different ways to prove triangles congruent. We could measure this distance from A to C, and he actually did that. He then measured the distance from C to D. He then knew that there was a 90-degree angle here and a 90-degree angle here, and then this angle is vertical. So by angle, side angle, and angle, side angle, he knew the distance of D to E. So he could actually measure this. And the measurement from D to E would be the same distance as A to B. And that's how he would know the distance across the river without actually measuring the distance across the river. So this is yes by angle, side angle. And the 2 triangles are congruent because we have a statement now that we could say triangle ABC is congruent to triangle. Now watch. A went with D, B went with E, and C went with C. Now watch. All he would have to do now is know the measurement of D to E, and D to E would be the same length as A to B. And that's how he would find that distance without actually having to measure across the river. He would just measure the distance from here to here. Okay? And we're using one of the knowledges that we had of angle, side angle. All right. That moves us on to this one. It was reported that one of Napoleon's officers estimated the width of a river as follows. The officer stood on one bank of the side. So he stood up the bank. He's standing there perfect. He's looking across. And as he looked across the river, he lowered his visor, lowered his hat cap until he saw the farthest edge of the river. Once he saw the farthest edge of the river, he turned his body and looked down the river, and then he walked that distance. Well, once he walked that distance, he knew that he walked the distance that he exactly saw, how far, like he saw something in the distance that he saw, and he walked this distance right here. Well, then he knew that distance right there would be the exact same distance right there, because this angle is a 90 as well, and then this angle, well, in fact, it's not that angle. It's the height of himself. So I'm going to redraw this picture for you. So he knew that himself, he was a certain distance. His height was, let's say, 6 feet. Well, 6 feet is the exact same for this triangle and same for this triangle. And then when he walked that distance, he knew that he had the distance of the exact triangle. So he has a triangle of, and I'll draw it a little bit. I'll draw it like he has it. Okay, and we're going to say F, D, E. We know that's a 90. We know his height is the exact same for both pictures. So watch, this is E, this is D. Notice, DE is the exact same for both. That would be reflexive. And then this is a 90. And then when he walked this distance right here, boom, then he knew that that distance was the same as that distance. And we have side, angle, side to prove that the two triangles are congruent. So that would be yes, by side, angle, side, the two triangles are congruent. So we would say triangle FDE is congruent to triangle. If I said F, I've got to say G. And then if I said D, I've got to say D. And if I said E, I've got to say E. And the distance he wanted was across the river. And if if GE, so look at this, G to E, those two letters are the two farthest ones apart. If that is the same distance as F to E, then he's got it. And so without actually having to measure across the river again, they would have that distance of that across the river just by walking up the bank. So that's how he would have done it. So we're proving that by side, angle, side. All right, explain how you can use the given information that proves these hang glider wings are congruent. Okay, well, we'll see what we've got. We're going to take the information they've given us and we're going to put it on the picture according to what they've said. They said angle 1 is congruent to angle 2. So angle 1 is right here and it's congruent to angle 2. Okay, well, I'll go with that. They then say that, now follow the letters, RTQ. So RT to Q, that's this angle right here. I'm going to do 2 marks. Okay, now they're saying it's congruent to RTS. RTS, so it's this angle right here. And those are the only things that we have. Now I'm going to separate the picture, so watch. Now watch what happens when I separate the picture. Watch what I do with side R to T. So we've got Q, 1 mark. 2 here, and this is T, and this is R. Now watch, I pulled this side apart. So watch, R and T. Now R and T are going to be the exact same, you guys. So I'm going to put 2 marks there because those were the given. And this is S. So we've got 1 mark, 1 mark, that was given. 2 marks, 2 marks, that was given. And then we personally, by reflexive property, because RT to RT would be the exact same length, we can now prove that these two triangles are congruent, yes, by angle, angle, not included side. So, yes, by angle, angle, side. And then, yes, the two triangles are congruent because we're trying to prove that Q to T and S to T are congruent. Well, watch, if the two triangles are congruent, which they are, then we've got Q to T and S to T that would be congruent. And the statement would look something like this. Triangle QRT is congruent to triangle. Now watch, Q went with S, R went with R, and T went with T. And what did they want to prove? QT, same letters, they're apart from each other by R, and ST, they're apart from the other, so they're in the right spots, we've got congruence. So we're good, we just proved it by angle, side, angle, angle, not included side. All right, let's go on to this one. This one's a little bit like the Napoleon one, and the one we did before that. All right, define the distance across the river from point N to point P. So they want to find this distance. First, place a stake at point K. So they said put a point, so place a stake right there on the near side of the river so that N to Q, or N to K, so N to K will be perpendicular to N to P. So they're saying that has to be a 90, and they're showing that. Okay? Says then find point M, so point M, and make sure that it's directly in the middle. And if that's directly in the middle, we can put a mark here. So I'll do that with this blue mark so you can see it a little better in this. And then you can see the box is the 90. So far that's what they've told us. And now finally locate a point L. So they said locate a point L so that NK is perpendicular to KN. So now we've got a 90 here. So now what can we prove? We want to be able to prove the distance of N to P. Well, the only way we can prove that is if we have the distance of L to Q. And if that's true, we'll have it. Well, do we have congruent triangles anyway? Well, here, let's see. We've got vertical angles here, so I'm going to put one angle mark. I'm going to do that in red because it's a little easier to see. And one here because of vertical angles. So now are the two triangles going to be congruent? Yes, because of angle, side, angle. Angle, side, angle. So, yes, by angle, side, angle. And now triangle, watch. I'm going to name the top one. NPM is congruent to triangle. Now, if I said N, I've got to say K. Because N had a 90, this has a 90. P went with L. And then M obviously is with M. Now, what did they want us to find? They wanted us to find the distance across the river. So that was N to P. So N to P better match K to L. And it does. N to P matched K to L. And so we've got it. And that would be able to be how you found the distance. So you would measure this distance from here to here, and whatever you got on that distance would be your distance across the river, give or take. That's how surveyors do this. So surveyors make this happen just like on this picture right here. Surveyors make this happen. This is like a real life situation. So, okay, here's the last slide. It says, how can I explain? So explain how you might prove angle A is congruent to angle C. Well, let's see what we've got. We've got two triangles, one on the left, one on the right, and they've got two markings here, we've got two markings there, we've got one mark here, and we've got one mark there. Right now, we don't have enough information until we pull it apart, and then we mark the side that was together. So watch, I'm going to redraw the two triangles, A, B, D, one mark, two marks, three marks. Watch, B, D, because that's the exact same, and then two marks, one mark, and C is there. So now I'm going to say yes, the two triangles are congruent by side, side, side. So now let's see if they match up with the angles. So triangle A, B, D is congruent to triangle. I said A, I got to say C because it goes 2 and 1, 2 and 1. B has 2 and 3. So find 2 and 3, and that's B. And D has 1 and 3, so find 1 and 3, and that's D. So now let's see if the angles match up. They wanted to know if angle A would match angle C. Angle A matches angle C, and that's a yes. So I'm going to say yes by side, side, side. So we just went through 4 or 5 different slides of proving that triangles are congruent by different methods. Remember, there's 5 ways. So there's side, side, side. There is angle, side, angle. There is side, angle, side. There is angle, angle, non-included side. There is angle, side, angle again. And there is side, side, side. So there's several. The only one we did not talk about was hypotenuse leg, but we didn't need it in any of these examples. So that's kind of what you're going to do in lesson 12-7. Good luck with it tomorrow. Let me know if you have any trouble. Give me a call. You guys know my number if you need it, or email me. And good luck. Keep it up. Keep working hard. And no matter what, shake and bake. Thanks.